Okay folks, it's 9:55 on the 4th of August 2025. The moon is probably in its 8th day. You're having a look at a 2.5 second exposure, 42 flood, 128 flood, 42 decibels of gain. I'm using a handheld handheld Canon imaging system, a camera, and we're viewing, of course, Messier 57. What I'm going to do tonight is push things a little bit. The sky's not too bad. It's well into sky dark now, and I just completed a view of the moon in order to see if anything flew in front of it for 15 minutes. That's in a previous video that I will post. This one will be posted up after that one on the manana. So there's an overexposed view of the Ring Nebula in Lyra. And moving on. Okay, here we're getting a much better view of the dumbbell Messier 27 at Aquila than we did the other night because the sky's a bit clearer and the local fairgrounds are no longer being flooded with light for the rodeo. You can see the I can see the football shape of the dumbbell. It's only a 2.5 second exposure, but this is a pretty decent shot of it, given that we're using the REV II system and we're using the 6-inch f4 without a reducing Barlow. So not a bad view for 2.5 seconds, comparable to what I would get through the ZWO system on the 150 millimeter semi-apochromatic refractor in the observatory. However, we're only getting a 20 by 15 arc-minute field of view at roughly 75x. Okay, here we're watching a rather overexposed version of Messier 13 formulating on the screen. I'll put it in the high contrast region, which is right above the dark bar. So Messier 13 is looking pretty good. Now remember, this is only 2.5 second exposure. Typically the minimum exposure time I do with the ZWO is 5, and sometimes if I'm really still in the observatory, I can get up to a 60-second exposure without disturbing the stars too much. Not bad. Alright, what I'm trying to capture now is a 15th magnitude galaxy. Don't have much hope for it because the moon's out. Sky is okay, but it didn't look as clear as I might. We're looking for Polarisma borealis. It's NGC 3172. Could be somewhere on the screen. It's just very hard to tell. I can see a double star up here, so we're getting a fairly sharp view. Where's that double star? Yeah. I'm not sure whether or not the Canon power shot is actually perfectly focused. It's got a rather small screen on it. But I will sweep using the dark bar, and this is about where, just above the dark bar is the high contrast region. That's about where Messier 13 turned up, but you never can expect everything, all parts of the sky for studies to turn up on the right part of the screen. So let's do a little sweep. And possibly it'll turn up. It's fairly small, less than an arc minute. We're only operating at 75x. So there's our sweep. One more time going down quickly. And let's move on to Messier 81 and 82. Okay, here we have Messier 82 developing on the screen. Typically, on a very decent night of seeing, a 5-second exposure will show you swirling spiral arms using the ZWO imager on this particular telescope. But we're using the REV II at half the exposure time, which typically means you lose about 0.8 magnitudes in reach. Meanwhile, I did notice high thin clouds earlier and we have a moon out. So my hope is that in the future, we will be able to image the spiral arms using the REV II system, because this is going to be the preferred system for doing deep sky in terms of portable deep sky views without an eyepiece and expanding the aperture of the scope up from about 6 inches to 18 inches. It makes for a nice compact package to do that. And if we can see that, oh, I'm seeing the spiral arms extension, folks. That is an accomplishment. Can you see them? I'll push the contrast up to that part of the screen and down. Absolutely, this is really working out quite well, especially given the current conditions. Spiral arms at 2.5 seconds, 42 decibels, auto gain control through the REV II system, operating using a 150 millimeter fast Newt reflector on a Skywatcher 6 EQR mount. Very, very nice. Thank you for that, the Cosmos. Okay, what we're seeing now is our view of Messier 81, which always gives a better, higher contrast view than Messier 82, which always gives a brighter, higher contrast image than Messier 81. And it's obvious why, because it's edge-on appearance, but it also has remarkable texture in it. This galaxy is being tugged at gravitationally by more massive Messier 81, and I believe they're within that. Now they're about 25 to 30 million light. Well, no, is it 12 million light years distant? I believe so. Anyway, the data facts don't always call to mind that well. But here we are getting a very good view of a pair of. This is the second in a pair of galaxies that are. Oh, we just had something pass through the screen, and we can evaluate that for what it might reveal. Anyway, we are getting a very nice view, and I would say these views are comparable to a double-digit aperture scope, probably 15 to 20 inches right now under these conditions. Very, very nice. Okay, now I want to go after some faint galaxies virtually overhead to characterize what we can see better using the REV II system on El Quattro, the F4 Newtonian fast reflector. Remember, these aren't the best of conditions, these aren't the worst of conditions. What I'm going to do is step through, as long as I have some battery left on the Canon PowerShot, a series of galaxies that are virtually overhead. This one is NGC 6600, and I'm basically going to step through them. I have no data that I've found yet on the database or handset associated with the Skywatcher 6 EQ6R Pro mount. Data may be available on it, but it doesn't flash up when you use the Go-To. I believe NGC 6600 is right there in the middle of the field. It's giving a good view. However, it is not. I cannot present it particularly well using a handheld camera. This, once again, the image, the vision I am seeing on the screen is better than what you're seeing on this camera. There's no dark bar at the bottom and no bright luminosity at the top. The camera, oh, we had another transient. This one's slower. Anyway, probably a satellite. Anyway, so we are getting a view. I'm not sure what the magnitude of the galaxy is, probably nothing more than 13.5. I am shooting for imaging something reliably down to a magnitude 15, which would give us views in the 18 to 24 inch aperture range. But if I were someplace like 6,000 feet in Crater Lake, we would get some really spectacular views, but this is just from backyard John Day, Oregon. What I want to point out is because I have this scope in the grass in the backyard, I'm able to see everything down to Polaris. So this is I believe this galaxy, NGC 6601, is in Draco. I'm seeing hints of it on the screen. Now what I want to tell you about it, let me back off a little bit, it gives a little better view. What I want to say is it typically takes about 30 to 35 seconds at 2.5 seconds exposure time, plus stacking, to be able to get a fully exposed image that looks good on the screen. We're probably into about 20 seconds now. But one thing you learn with the imaging system, especially the REV II, is stars pop out quickly, but galaxies will kind of unfold in luminosity before you. So it makes them a little easier to see anything that's nebulous because it will reveal itself over time. I'm not sure where this particular galaxy is on the screen, but I'm doing my best to capture it on the Canon Power Shot. Okay, our next study is the NGC 6602. I've initiated image capture on the Canon Power Shot roughly 15 seconds after navigation, go-to navigation to it. Once again, the screen looks really good to my eye, but doesn't look particularly good on this handheld display of the Power Shot. Basically, this is NGC 66, I believe it was 02, and we should be looking for it to slowly reveal itself. I believe it's somewhere in this region of the screen there. I'll scan up a little bit manually. I will post up the data from Steve Gottlieb's Adventures in Deep Space website, which I recommend any amateur astronomer consult for data about how things appear. He basically talks about scopes ranging from early on about 8 inches in aperture till the 20s, 10s and later, where he had access to a 48-inch scope. All are eyepiece observations. He's an excellent observer. He knows his east from his west, his north from his south, his position angles. He describes deep space studies very well. He gives references to nearby stars so you can determine whether or not you're actually seeing what he is describing by reference. I also recommend looking at digital sky survey images. They were done with, most of them were done with a 48-inch Palomar Schmidt camera in the 1940s, 50s, and those images are very good because they give you 20 to 60 minute photographic plate images converted over to digital format for posting on the web. So there we have it. Let's move on to our next study, NGC 6603, if it's in the sky's middle third. Okay, this will be our last study. We've had to skip to NGC 6606, largely because the others were far too far south and the moon is basically obscuring anything there. I think we've sampled about 4 or 5 galaxies in the NGC series that should give us an idea of what kind of views you can get on the REV II, roughly, limited by the fact I'm using a handheld camera to capture them. And I would say that ideally we are going to be able to image C studies down to about magnitude 15 under reasonable conditions using the REV II system with the fast f4 150mm Skywatcher L Quattro Newtonian. Let me scan this a few times so we can get it in the high contrast region. And then I will, as I mentioned earlier, I will attach data. This video is running a bit long. Let's have a look at the Crescent Nebula, and maybe something else will pop for me before we knock off for this evening. There we go. Folks, I am delighted to tell you we are getting a solid view of the Crescent Nebula NGC 6888, which I believe was a novel discharge, a novel remnant, not a supernova, but just a novel remnant. We could have a look at the Witch's Broom, and that would be 6960, I believe, because we're getting such a good view of the crescent. We may want to have a look. Remember, I am using a Lumicon Deep Sky filter to help cut down on the light from the moon and local light sources. Wow, I've got the handheld camera held in the perfect position right now. I wish I was able to always find a good position like this to hold it, but unfortunately the scope is constantly changing its orientation, complicating that factor. This is a fine view at 2.5 seconds exposure time, and using the f4 Newt and REV II system at 42 decibels gain. This reminds me of the views I used to get when I was using the 150 ED refractor and the REV II system in the past. Unfortunately, although I have a massive library of these studies, and I just do not have the time to go through them and do comparo views. I'll leave that up to somebody who might be motivated to go on to our Golden Phoenix Publish YouTube site, finding old images and doing some screen caps, and then comparing them. They won't be as good as the original postings because they reduce the resolution perhaps a bit when they process them, and certainly I have to process them on the laptop before I upload them. This is probably the finest presentation I've gotten yet of any of the screen offerings on the monitor system that was associated with the REV II system. So this one more closely approximates right there what you can get at the eyepiece, or by eye, sitting here in front of the screen. Let's move on to 6960 and 6995. Have a look at the eastern and western veil, and with that we will call it Carpe Noctem, because I've only got a couple of bars left on the battery of the Canon PowerShot. Okay, here we're getting our emerging view of NGC 6960, the western veil, otherwise described as the Witch's Room, with 52 Cygni, that very bright 4.8 magnitude star just above it. I can see the Witch's Room quite reasonably. It's not the greatest view, sweeping down over here in this direction, but it also continues off to the right. Not the best view. I thought the Crescent Nebula turned out better, but it is quite present on the screen. It doesn't take a lot of effort to get a sense of some texture in it. All right, let's go have a look at 6995 for our Carpe Noctem view. Okay, we're now on to NGC 6995, which is a little more present and gives more texture than 6960. This is the eastern veil. Once again, we're only using a light pollution filter, not a nebula enhancing filter. Both are the remnants, about 2.5 degrees across by this point, of a supernova that exploded in Cygnus, eastern Cygnus, about 15,000 years ago. The supernovas in general seed the universe with all the substances that are needed in order to create life. This has expanded quite radically, much more than the Crescent Nebula. The Crescent Nebula is only about 20 arc-minutes in size. This baby, when you consider from the eastern to the western, is about 2.5 degrees, or about, I think it's over 210 arc-minutes in diameter. We're getting some really fine texture in this view of the screen. I am going to play with the screen settings just a little bit to see if we can't improve presentation. My eyes are being a little overwhelmed by the brightness of the screen. So what I'm going to do while I hold both cameras, I'm going to reduce the brightness to 50%. So we can see if that's an improvement in terms of image quality on the Sony Handycam. All right, it doesn't look, it's a little better to the eye, but I don't think it really improved it that much on the camera. I think it had a flatter view, so I'm going to press it up to about 75% brightness. Now the other function we can deal with is called contrast. I'll move that up. See what we can do with that. It seems to have brought out the nebulosity more. So what I'm going to do is reduce the contrast from 25, increase it to 50 when I'm reducing it from what we have now. And I think this is a pretty good compromise. So with that, I am going to say Carpe Noctem.